While experimenting, Michael Faraday made a very important discovery in electromagnetism, now known as Faraday's law of electromagnetic induction. Faraday's discovery has given birth to applications like transformers, generators and AC motors. And hence it is very important to every electrical engineer to understand this law, as it will make learning of these equipments reveal a fundamental relationship between the voltage and the flux in the circuit. So let's see what exactly he revealed. He discovered two important things. Number one, if the flux linking a loop or turn varies as a function of time, a voltage is induced between its terminal. Let's hear it again. If the flux linking a loop or turn varies as a function of time, a voltage is induced between its terminal. This means that, let's say, if you have a coil, a copper coil, which is surrounded with flux, and if you vary the flux which are linking to that coil, a voltage will get induced across the terminal of that coil. Now, it really doesn't matter if you vary the flux or the coil. It is also important to know what amount of voltage will get induced and on what basis the value of induced voltage depends. Well, we don't have to worry about it, as Faraday has already told us that, which is the second statement of Faraday's law of electromagnetic induction. The value of induced voltage is proportional to the rate of change of flux. The faster the flux will vary, the more voltage will generate, and vice versa. We can put this statement in mathematical form also. If flux varies inside a coil of n turn, the voltage induced is given by E is equals to, where E stands for induced voltage. So E is equals to N multiplied by the change in flux divided by change in time. Let's take an example. You have a coil with 1000 turn which is surrounded by a flux of 6 milliweber produced by a permanent magnet as shown in the figure. Now the magnet is suddenly moved and the flux inside the coil reduced to 3 milliweber in 1/10 of a second. What will be the voltage induced? So we can use this formula to find out the total amount of voltage induced. If you do the calculation, you will find that the total amount of voltage generated is 30 volts. And this proves the law of electromagnetic induction. This law is the basis of a working principle of transformers, generators and AC motors, and that's why it is so important. Now, as you have understood the basics of Faraday's law, I'm pretty sure that you will also going to understand the basic working principle of transformers, generators and AC motor. So guys, that's all for this video. I'll see you guys in my next one, but till then you have